Okay, good afternoon. We're just going to give some minutes for people to get in. Okay, we wait one more minute and then start. Okay, I think we can get starting, otherwise people will join. So good afternoon, everyone. It's a pleasure to welcome all you in another webinar of C5Lab. This time in collaboration with the organizer and participants of the Cost Action TrANsMIT, more specifically a techno-economic analysis of carbon mitigation technologies, Cost Action. In the next hour or so, we will get to learn more about the activities of this networking group of researchers and industry, together with industry. C5Lab has already taken part in several training courses, various workshops, a virtual mission as part of these networking activities. And we also have participated in the contribution to the open access database and some modeling and results and experiments regarding the CCUS. Before presenting our guests, I would just like to say some few words regarding C5Labs. For the ones that do not know us, I will be brief. I think now my screen is being shared. So C5Lab is, it's not in presentation mode, sorry. Okay, so C5Lab is a laboratory, a collaborative laboratory between academia and industry that has as associates the International Association for the Cement Industry, Simpor and Cecil, the two cement plants in Portugal, IST from the Lisbon University, and the National Laboratory for Civil Engineering. We work together towards the decarbonisation of the cement industry in order to achieve carbon neutrality. At the moment, we are 21 researchers working in different areas, research areas. So we have area one more related with CCUS, so CO2 capture, utilization and storage. That's basically taking care of the flue gas of the cement plant. Area two, more towards the transition and energy efficiency of the process. So whatever has to do with renewable energies, energy optimization, and the reduction of the dependence of the fossil fuels. And then area three, more related to the product of the cement plants in itself. So development of innovative new sustainable cementitious materials. Sorry. Internally, we have 8 action lines that covers all these 3 research areas. I'm not going to go into those, but basically, as I said, they cover all the 3 research areas. They are internal projects together with the industry. And besides that, we also have national and international projects and involvement in cost action as the one we are collaborating and presenting to you today. Being a non-profit association, we still need to make money for survival, and so we have some services to provide: consulting, R&D and experimental analysis, training, project collaborations, research, and so on. So thank you all for the attention, and I think now it's time to pass to our guests. So I'm proud to present, and thank you for the acceptance of the invitation, to Anna from. Anna is a professor at Silesian University of Technology in Glizik. I'm not sure if I'm pronouncing correct. Also, your name, sorry, I'm not pronouncing it. From Poland, in the Faculty of Energy and Environmental Engineering. A research focus on energy system, environmental engineering. Sorry, just gonna. Environmental engineering, decarbonisation pathways, modeling, techno-economic analysis, and life cycle assessments of low carbon technologies, including carbon capture and storage. She is the coordinator of the TrANsMIT Cost Action, leads also the Net Zero Poland project. This is a project that explores pathways for achieving net zero emissions in Poland by 2050. She has led and contributed to numerous national and international research projects, initiatives, and collaboration with industry, and as the authorship and co-authorship of many scientific publications. And Anna will now talk about strengthening collaboration in carbon mitigation technologies within TrANsMIT activities. Welcome you, Anna. Please, the floor is yours.
Yes, thank you very much, Joseph, for this introduction. Thank you for inviting me here. It's always
Welcome.
Great to collaborate with C5Lab and you people. This is one of the best parts, and I will probably underline that throughout my whole presentation, that people are making this cost action, and we had a really we were really lucky, or we have been very lucky for having such people like the team from C5Lab here in the TrANsMIT. So my role today is to basically present the action. I guess some of the guests might know already, but well, I will try to go back to the origins and present what are the main goals and how we are trying to realize that. So basically, for maybe those who don't know what is actually cost action, it's an initiative in the interdisciplinary 4-year research network funded by COST, so European Cooperation in Science and Technology Associations. And the main idea is to build a network in any topic. So some years ago, a group of people, we were talking together and started to, people dealing with CCUS broadly, mainly process modeling, techno-economic analysis. We sat down together and were thinking what is, let's say, what are the challenges, bottlenecks in what we are doing. And we found out quite some of them, and I guess most of us are aware of them. So maybe it's even better visible here. We all know that there are different elements of the whole value chain, and usually we are dealing with one or maybe two of them, like for example with CO2 capture, maybe with transport, maybe with utilization or storage, but usually just part of that, and we do not really know a lot about the rest. So I'm mainly, for example, I was dealing mainly with CO2 capture, later also with CO2 utilization, but I have no idea about challenges, problems of storage. Also, of course, we are dealing with different sources. We are dealing with CO2 in power generation, in industry, like C5Lab, mainly in cement. Of course, there are many industries. We can also deal with CO2 in atmosphere. So this is a very large and long chain that has to be covered. And we wanted to gather the specialists, the experts, but also the newcomers in all of these elements, just to talk to talk about the challenges, to talk about what we can like really do to speak the same language, kind of, and of course to learn from each other. So we stated, I will not go through through those challenges in details, but we just stated, put down on the paper some of the key, and we build the network around that. So the idea of cost actions is that you can come up with your own topic. So any topic is okay. It can be broader, it can be more narrow, it can be more dealing with like here, like modeling, maybe more in I don't know, in experiment, and any topic is kind of possible. So this is the good thing. However, it also gives, I mean, you have to compete with a very broad range of topic. So it's not, I would say, it's not very easy to get, and we didn't get it for the first time, but we were patient and we managed to get this financing. So what our aim was to like develop a network around whole value chain of carbon capture, utilization, and storage. We wanted basically to bring together various like stakeholders. Of course, it's usually around research, academia, usually led by people from this kind of institution, but we wanted to collaborate also with industry, which is very important in this context. We wanted to come to also to like broader society. And one of the main goals was also to like to establish a network of young scientists, or like build a platform for young scientists to like talk together, to meet, to get some training, especially that we have people from different countries around Europe, more developed in CCS. We know that some countries like Norway, UK, or the Netherlands, basically they are more developed, and Denmark in CCUS, while some others are less developed, and it gives the opportunity to discuss, to learn, to meet people from other, not only countries, but also like other type of stakeholders and so on. In cost, there are no money for research, but there is money for networking. So you can organize workshops, training school, you can go to conferences, you can have scientific missions. So send people to other collaborator in the network to do something together, basically. So for a research stay, it can be both in the industry, but also at another research or academia. Well, we can organize some dissemination event and so on. So basically, the way of networking is by like meeting between people. There is no really money for doing any research that has to be secured somehow else, but definitely it helps to meet, to network. Yeah, as I mentioned, we have different stakeholders in mind. Well, of course, one of the challenges is to attract other than academia and research institutions. We are usually involved and interested by definition, but I think we also managed to have some industry at least attracted and somehow involved and interested in what is being done. Hopefully, can also reach some. We managed to reach some level of administration, policy makers, and so on. Within TrANsMIT, we have 5 working groups, originally 4, and then we added life cycle thinking in CCUS as we thought it is also very important, and like making in a full together with process modeling and techno-economic analysis, a holistic, very holistic approach. So we have so-called 5 working groups that are focused on like the main goal. We have already a lot of partners. This is the last year of TrANsMIT, so that is also kind of easier to have a lot of participants. We have so-called 54 members of management committee from 29 countries. That might be only 2% from each country in a management committee, having the right to, let's say, to set directions or accepting some decisions of the whole actions. So we are covering many countries in Europe, as you can see, but also from outside. So basically, a member can be also from outside, although there are some rules for participation and financing. We have, well, a lot of, like, more than 50% of young people, which is nice. So-called ITC countries, which you can see in blue in this map. These are those called inclusiveness target countries. So let's say less, a bit less developed compared to the rest, which gives more opportunities for people attending from those countries. So we are quite broad network. Of course, I have to say that not all members definitely are active, but I think after these 4 years, we have like a group of 50 people, let's say, that we can call TrANsMIT friends. That people that we can really collaborate with, easily reach, like José from C5Lab and other people, Anna Sofia from here. And this is the best value of the project. What we did, just very briefly, we have a web page. You're more than welcome to visit that. We have a LinkedIn account where we are, in both these places, we are trying to put updates, calls that are open for any event we have, and basically to show what we are doing. And yeah, we have some newsletters published that can also be found there. We had a couple of meetings, very nice meetings. At what you can see here are people that are like that have been taking part in some of the events. All of them, I would say, are, I mean, amazing and happy, and that's because the meetings we had are really, I mean, this is really what makes you feel good being part of this network. A lot of discussions, very fruitful discussions. We managed to prepare some reports from this, and also what is definitely the outcome is kind of a bunch of projects, common projects between partners that only met in TrANsMIT. So this is really a network that helps meeting, other people working in research or industry that found a common topic to submit a proposal and even get the financing from different sources. So yeah, workshops, other kind of meetings. A couple of people each year go to a conference to present the results. We had something like training school, mainly for young researchers, like PhD students and postdocs, but basically open to anyone, where we share the knowledge of experts with these younger folks. So yes, this was like throughout 4 year of TrANsMIT, we still have something to come, and this basically is our TrANsMIT training school in Milan in June this year. This is what still is in front of us, and then we have a final conference to present broader what has been done in TrANsMIT, what we managed to achieve, and to just make some summary. You are more than welcome to join also. We'll of course share the call and more information on our social media and the web page. And yeah, this is the way to also get into contact with others. So also, as Jose mentioned, we have something like open access database, which we are trying to develop for the last already like at least second year, which should be like a digital home for the whole community. We want to have a database where we can find mainly experimental data for your that can be used for your models, for your work, a database that is can be trusted. So we are of course basing on what can be found in the literature. However, everything is verified, introduced in a specific way, and you can make use of that in a license. Should be open. We still need to finish that, but the works are definitely ongoing. We also are going to produce some final reports based on these collaborations and talks and these let's say full meetings. Hopefully it will serve to the CCUS community. And well, this is almost the end. What I would like to underline is that well, it's not an let's say easy project, I would say. First of all, because there is no money for research, there is no money for remuneration of anyone. So basically, everyone is doing anything for free. So spend part of your precious time to work for TrANsMIT. Of course, we can pay the travel or accommodation, but this is for me. It's not enough for people for their work. So I can only say thank you for those who are in TrANsMIT and who are devoting time to develop that. And I think also this is the best part of cost action. And I think in TrANsMIT we are especially lucky to have really a bunch of people that are wonderful, that are spending time, that are always helpful, and that if we meet, we feel like good, at least colleagues, if not of friends. But I think we even developed some friendships within that, resulting in real closer collaboration, better attempt for projects even. And I think the goal for the moment has been achieved, especially the one concerning networking, concerning exchange of knowledge, concerning connecting different parts of CCUS value chain. This is not, I mean, the cost action is TrANsMIT is slowly going to the end, but I think we are much, farther, much better than we were 4 years ago. So thank you very much. If you have any question, I'm happy to answer. If you want to join, still there is time. We still have some months in front of us. If you want to collaborate, feel free. Thank you very much.
Okay, thank you very much, Anna. It was a very nice highlight of what you have been doing, and also, yeah, I can testify that from the few cost actions that I've participated in TrANsMIT, whenever we get together, we actually do some work while we are together, and that's probably also part of the fun, let's say, in TrANsMIT. While in other cost actions we go there, you present the work that probably you have done yourselves, despite getting the networking. But I think the way TrANsMIT works, it's quite nice actually. Thank you for all the organization. I forgot in the beginning to say that there is a Q&A section here. So if you make up some questions, we can then take them in the end. I will give you some time to write questions to Anna, because I didn't mention it in the beginning. And now we will move forward to Sara Pascual. So Sara, thank you also very much for your acceptance. Sara is a PhD assistant professor at the University de Valladolid. She is specialized in net zero carbon energy systems. Her expertise spans bioenergy with carbon capture, thermochemical energy storage technologies, and industrial decarbonisation systems. Her award-winning bachelor's thesis on carbon capture in livestock waste recovery system was recognized by the Spanish CO2 technology platform. She obtained her PhD in renewable energies and energy efficiency from the University of Zaragoza in 2023. She also has been involved in two projects related to the decarbonization of the iron and steel industry through green hydrogen and CO2 recirculation, CO2 capture and methanation. For the industry through power to gas and carbon capture solutions. So Sara, welcome. The floor is yours.
Thank you so much, Jose, for the presentation. And also thank you again to the C5Lab to organize this webinar, and also for the invitation. First, I begin with this slide. First, to have one of the that I am one of the part of the research group Energy and CO2. With this research group, it belongs to the Aragon Institute of Engineering Research, and within the University of Zaragoza. Today, I would like to share with you our experience in the applied research, in this case for industrial decarbonization, especially in carbon capture, utilization and storage process, and also the integration of technologies such as power to gas and bioenergy systems. The goal is not only to present the research projects, but also to explain how these solutions can be transferred to the real industrial sectors, especially those considered hard to abate, such as steel, cement, and also whatever energy-intensive thermal processes. To better understand our work, I will first to briefly introduce who we are and on how our research has evolved over the time. The Energy and CO2 research group has more than 2 decades of experience in industry-oriented research. Our evolution can be divided in 3 main phases. The first one, from the 2000s to 2050, focused on the conventional carbon capture technologies, especially in post-combustion oxy-fuel systems. The second phase, between the last year 2050 and the 2025, represented a transition towards bioenergy carbon capture systems, the CO2 utilization, and also power to gas applications. And currently, we are in the third phase, focused on the advance of CO2 valorization and large-scale industrial decarbonization solutions. This evolution reflects how challenge itself has changed. We move from the CO2 capture to asking how CO2 can become part of the solution. So our mission today is clear: to advance for the decarbonization through innovative CO2 solutions like CO2 capture and also the CO2 valorization, and also the use of biomass and the sustainable energy storage alternatives. So our team, you can see here on this slide, is composed of two principal investigators. First, Professor Luis Miguel Romeo, and also Professor Luis Ignacio Diaz. Then we are involved 40 permanent members, also 12 faculty members, 2 postdoctoral researchers, and 5 PhD and master engineering students. All of them have a strong interdisciplinarity across chemical engineering, mechanical engineering, physics, chemistry, and material science. This diversity is also essential because industrial decarbonization is not a single problem challenge. It refers to multiple perspectives working together. And this approach is directly reflected in our research objectives. Our work here is focused on 3 major objectives. First of all, the use of renewable energy and also the thermochemical energy storage system. The second one, the improving CO2 reduction, capture, transport, storage, and also the utilization of this CO2. Especially where the direct electrification of different processes is currently not feasible. And then the third one, always the evaluation on or evaluating the technical, economic, and also the environmental feasibility of the proposed solutions. This last point is especially important because the technology may perform successfully at lab or pilot scale, but this is not economically viable or environmentally consistent. It will never reach the industrial or the commercial scale. That is why our research always tries to connect the scientific innovation with the real industrial applications. These objectives are also translated into several practical research lines. Our research group are currently working in these 4 research lines. First of all, the carbon capture and utilization to convert the CO2 emissions into valuable products, closing the carbon loop and reducing industrial emissions. The second one, the biomass and biogenic carbon capture to harness renewable carbon sources and enable negative emission pathways through natural engineering process. The third one is the research line based on energy storage to provide the flexibility and stability to the energy systems, enabling the integration of the intermittent renewable sources. And the last one, which is the industrial decarbonization to drive deep emissions reductions across to the hard-to-abate sectors through electrification, indirect electrification, process innovation, and also circular carbon strategies. These 4 research lines are conceived as an integrated approach where carbon is captured, used, stored, and managed as part of a resilient, low-emission industrial and also energy system. Then I'm going to detail these 4 research lines. The first one is also based in the carbon capture and utilization process and also to the power-to-gas technology, where we developed the process simulation, the optimization, the techno-economic analysis, and also the life cycle assessment for the CO2 capture and its utilization. And if you need for information about this research line, you can contact with the principal investigator, which is the Professor Luis Miguel Romeo. You have here the contact if you want. Then the second research line, where we focused on the cost-effective carbon capture based on bioenergy resource and biomass conversion. And if you need additional details about this research line, you can get in touch with the Professor Luis Ignacio Diez, which is the principal investigator in this line. Then the third line, the energy storage, especially in the long duration of the thermochemical storage system integrated with renewable sources and also the hydrogen production. And this research line is or you can have more information if you contact with this principal investigator, that is Luis Miguel Romeo again. And the last one, the 4th area is the industrial decarbonization, which also includes the industrial gas pretreatment, the hydrogen and synthetic fuel integration, the waste head recovery, and also the carbon capture in industrial processes. For further information, you can see here in this slide the contact again with the Professor Luis Ignacio Diez. And I'm going to detail this research line because this is the most relevant for also this webinar, because also and also connects all the previously research lines into the real industrial applications, mainly for energy-intensive sectors such as the steel and cement production. The steel sector is one of the largest CO2 emitters, and it relies heavily on specifically on coal. To reduce these emissions, solutions such as the use of green hydrogen, the CO2 capture, and the production of syngas, like methane, are being proposed in the projects related to this industrial sector. The goal is to reduce the dependence on fossil fuels and, as much as possible, close the carbon cycle. On the other hand, we have the cement sector that presents different challenges. In this case, a large share of emissions that not come from fuel, but from the chemical process of the calcination itself. Therefore, technologies such as carbon capture are practically essential. Additionally, material substitutions and the use of waste, such as agricultural residues, are also being explored to reduce the environmental impact. However, both sectors share a common goal that it is essential for achieving the global development which is reach the net zero carbon emissions. First, I'm going to talk about projects related to the steel production. First one is one of the most relevant projects that analyze the steel industry and decarbonisation, exploring innovative power-to-gas based concepts to enable the indirect electrification of this sector and reduce the carbon footprint. To do this, we propose first the use of renewable electricity to produce the green hydrogen. In this case, the green hydrogen is used for a methanation, a catalytic methanation process to obtain methane to use as fuel for the hot metal production. In this methanation process, we need another reagent that is the CO2, and the CO2 is recovered from the steel production process. And then we also can close not also the carbon, the circular carbon cycle, and also we can close the water cycle, because for some of the decarbonization scenarios proposed, we can recover water to use in other process in the steel production from the methanation process. Additionally, first of all, additionally of these scenarios that then I'm going to talk about, the experimental assessment of the catalyst performance and also the reaction kinetics of this methanation process are also addressed in this project, including the influence of the operating conditions. And also for all of our projects, the technical, environmental, and economic assessment is essential to integrate this proposal into the existing industrial and energy systems. This project, we develop more proposals than this, but it is the main ones. First, technical, economic, and also environmental simulation of this steel industry decarbonization are implemented in these three main routes. First, or the last one, is the direct use of green hydrogen via the water electrolysis to oxy-fuel combustion in the hot metal production. This one is the CO2 recycle based on the amine scrubbing process to produce also synthetic methane to meet the hot metal production thermal requirements. Using also hydrogen from the electrolysis process, and the last one is the direct blast furnace gas methanation. In this case, we obtain the syngas for the hot metal production, supplying hydrogen from the electrolyzer. And in all this case, the results show that fossil fuel dependence and also the CO2 emissions can be significantly reduced with this in these scenarios. And regarding the environmental performance, it should be noted that it's strongly driven principle or mainly for the source that we use in the electrolysis process. And also it's important to highlight that the trade-off between the carbon reduction, the energy demand, and also the materials use. Currently, research members of this group are involved also in exergy assessments to perform the economic approach of these scenarios. Moreover, for further work in this project, novel configurations will be assessed based also in CO2 and also in waste thermal energy recovery. Once this system level 4 simulation show promising results, we address the experimental step. To complement this simulation work. Here in the experimental step, we analyze 2 catalysts and also the reactor design. We mainly compare ruthenium catalyst, which is highly efficient but expensive, and nickel catalyst, which are cheaper and more robust. We found that the calcium promote nickel offers a very promising solution because it improves the resistance to sulfur poisoning. And another emergent important research is the reactor engineering that is important as a catalyst composition. This experimental step demonstrates that the scale industrial process requires also integrated visions between materials and also the reactor designs and operating conditions. And then another project is this one. This is the decarbonisation of the steel production through biochar combustion with oxygen and pyrolysis gas methanation. This is also the first point of this project is to share the suitable biomass for industrial demand. And then through or via pyrolysis, this biomass obtained to energy products, that is biochar or also syngas. Then the biochar are experimentally characterized, or this project experimentally characterizes the injection of this fuel in the blast furnace technology, and for the syngas from the pyrolysis, we have a step in this project to characterize the methanation of this syngas to later use this synthetic methane obtained in this methanation process. And also, again, in all of our projects, we have to assess the techno-economic and environmental feasibility of this proposal. This is the lab scale reactor that we have to perform these experimental steps. We have here the conditions of also the fuel residence time, the temperature, the pressure of this reactor. And I want to highlight that this project is or has support of ArcelorMittal, which is a project partner, and have a wider expertise in the steel production over the world, demonstrating the strong industrial orientation of this project. And then the other one, hard to abate industrial process, that is the cement production. We know that this cement sector is characterized for the high global carbon footprint, mainly driven for the CO2 emitted in the clinker step. However, this is a valuable product which demand will be raised over the world as well as the steel production. In this case, this last project that I presented in this webinar is the valorization of agricultural waste as a pathway to contribute to this decarbonization of the cement sector. In this case, in a specifically region in Spain that's called Aragon. This one proposal or the aim of this proposal is to partly use agricultural waste as supplementary cementitious materials. In this case, first of all, the project includes the crop identification using a geographical information system for the agricultural fields. This based availability analysis also in a radius of the location of the cement production and the selection of the most promising residues. Results show that with unbarley straws ashes could cover between the 4.6 and 7.7% of the annual pollution demand of the case study. This may seem that this is a modest number, but industrially is highly relevant because it reduces the clean air consumption associated, which is associated the CO2 emissions. In addition, it introduced this project territorial circularity and also local waste valorization. This example shows that the decarbonization is not always about the entirely new technologies. That also this idea leads perfectly to continue with some conclusions for this presentation. I would like to close with 5 main ideas. First of all, industrial decarbonization is complex and a greater challenge. There is not a single solution. Second one, the carbon capture and utilization technologies are essential, especially for hard-to-abate sectors. The third one, that green hydrogen, synthetic fuels, and also biogenic waste enable the deep emissions reductions. And fourth, economic and environmental feasibility must always be linked to the technical feasibility. And also the last one, the future depends of the technology integration, indirect electrification, the CO2 cycle, the material substitutions, also to the energy storage. So we are not talking about the competing solutions, but this is probably the greatest challenge. And this is exactly the philosophy that drives our work at the Energy and CO2 Research Group. I include here in this slide the link to the webpage of our research group if you want to access. And however, this achievement is made possible not only for the work that have in this research group, but also by the support of initiatives as the TrANsMIT Cost project, which provides funding for conferences, research days, and both experimental and techno-economic assessment activities that my colleague Anna are talking about this. And thank you very much for your attention. Sorry for for the delay, and also we are always open to collaborate with companies for the industrial sector, technology centers, and also institutions that are interested also in accelerating the transitions towards the low carbon industry. And of course, we'll be happy to answer any questions and also discuss further. So thank you so much.
Okay, thank you so much, Sarah. It was a very nice presentation. So we have a couple of questions here, one for Anna and one for Sarah. I would probably start with the one for Sarah, but before reading the one that's on the Q&A, regarding the project of the methanation in the steel, so the first project you presented for the steel industry regarding methanation, in which TRL are you now, or which TRL are you aiming to reach?
This one, do you need, you know?
The first, yeah, that one.
The one with the proposals to.
Sorry, I didn't hear because I have too much noise here. Sorry, can you repeat?
I mean that if your question is about the proposals or the general information of the.
No, so
I don't understand
the project proposal will start at TRL, which TRL, and will end up at which TRL?
Which are real to the industrial. Okay, I think that in general, for specifically for the steel production, the direct green hydrogen, it's one of the scenarios that in the future could be a start. Or the hydrogen have a lot of problems for specifically linked to the security. And the other proposals which involves the synthetic methane production and also use this synthetic methane as well. I think it's the first scenarios that probably in the production of steel could be implemented, I think. But also, I think people say that why do you perform a methane when you can directly use the hydrogen?
Okay.
But I think the methane as well could be a key driver for this industry. I think so.
Okay, but in the next slide, in the catalyst development, you are still at the lab scale, right?
Yes, the catalyst development or the experimental test are proposed also for the first and the second scenarios. Most for the first one, because you can see here that the proposal is to feed the methanation step with the blast furnace gas. In this case, the blast furnace gas can have sulfur components that can reduce the CO2 conversion. In this case, in this methanation process. So the experimental step is oriented to this one, first of all, and also for the other one, but in this case, we have an intermediate process that is the CO2 carbon capture technology. And for this one, probably this methanation step is more clear because you can feed here the hydrogen and also a CO2 with high purity in this
Okay,
case.
so
Yes,
no, go on.
but economically, if you have more equipment, we have to have more investment. So the first one probably you can see in a medium place integrated in this steel production, but also it's important to characterize with experimental test the catalyst for the methanation process in this case.
Okay, so actually you touched one of the questions. So a researcher asks, so good afternoon, thank you for the presentation. To what extent do impurities in industrial CO2 streams limit methanation performance and catalyst lifetime? So you kind of touched those issues. I don't know if you want to add anything else.
Yes, if we test these both catalysts because the new catalyst also have high performance than other ones. However, if you have the nickel catalyst, which is cheaper than the ruthenium one, if you have this catalyst with promoters than calcium, we can mitigate the degradation and also limiting the reduction in the methanation performance, and also in the catalyst lifetime. But when we compare the ruthenium and the nickel catalyst, in this case, without promoters, both of them also reduce the lifetime. In the case, also, if we have or we introduce in the methanation step gases with sulfur compositions, sulfur elements, principle.
Okay. Okay, thank you very much. So another question, so for you, Sarah, and then I have one more to Anna, and then I think we close it. So good afternoon, Sarah. Thank you very much for the presentation regarding the industrial case studies presented. What are the key factors that determine whether a CCUS solution becomes economically viable at scale, particularly in energy-intensive sectors like cement or chemicals?
I'm going to read the question.
Okay, sorry.
First,
basically, what factors in the TEA models you...
Oh, in the TA models? Okay. Yes. First, I belong to these projects specifically in the steel production decarbonization, and also I work in the experimental steps and also in the environmental assessment. So for the previous simulations and also for the techno-economic assessment are other colleagues of the research group that have more information than me. If you want contact also with Pilar Lisbona, in this case, also for the projects of the steel, the decarbonization of the steel production, and also I think with the cement production you can contact with this assistant professor Pilar Lisbona, and also in this case of the cement production you can contact with Marta Gómez. Okay, with
thank you
this
very much.
both.
Okay, thank you. So the last one for Anna, and then we close it. So good afternoon, Anna. Thank you very much for your presentation. You mentioned the challenge of engaging industry. What specific mechanisms are you considering to strengthen this engagement and ensure that industrial needs effectively shape the scientific agenda of the network?
Yeah, thank you for this question. That's always a kind of difficult question. I mean, because there is always somehow a division between research and industry, while there shouldn't be any, because we work for industry work for us. One without each other does not exist, kind of. And if you want to develop, we need both, of course. It's well, it's not easy, but what I can see also in other projects, like different ones, is that early engagement with industry helps. So like really what we are trying to do is to go to the industry, to present what we are doing, to hear the feedback, definitely, to hear what they want to say. Of course, try to engage. Sometimes it's not easy because we as researchers, we need more time for development because we are basically operating at lower TRL, which means that some of our concepts are from the beginning kind of lost, maybe not from the beginning, but at some point we have to change it, we have to go to another direction, whatever. But it basically takes time, not only because we are slow, but because this is low TRL and we need to develop ideas from scratch sometimes a bit farther. And the industry needs to earn money simply, and they need solutions right now. So of course they want to have to give us the problem and find a quick solution, which is not always possible. And it's not only what we want to do, because we also want to develop new ideas and not only solve the existing problems. But the dialogue from the very beginning of the project, I think, is very helpful because then we can hear each other's voices. And I think, well, to be short, this is the most important part. And from that, of course, each will like draw towards himself, herself, but it really helps to find a common points to develop, to introduce the idea to the industry, which is extremely important.
Okay, thank you very much. It was very enlightening. So rest, it's just a matter of thank you everybody that participates, specifically to Anna and Sarah. And thanks whoever was sitting, and yeah, hope to see you soon.